Right. So according to the second law, rate of change of momentum is equal to the unbalanced force. Underline unbalanced force, right? This is not just force, it is the unbalanced force. So unbalanced force is proportional to change of momentum. mv minus mu is change of momentum, rate of change of momentum, right? To make it a rate, you have to divide it by time. This is change of momentum divided by time. Rate of change of momentum. So that is the unbalanced force. It is proportional to this. Then we can say F is, you can put a constant there and make it an equation. mv minus mu divided by t. Then get m out. We get v minus u divided by t. What is this? v minus u divided by t. Change of velocity divided by time. That is acceleration, right? So you can put acceleration there, kma. So F equals kma. Take it down. Quickly take it down. Right. Then below this, write down 1 Newton, just a sentence, right? 1 Newton is defined as, the force required to provide 1 meters per square second, of acceleration to 1 kilogram of an object, 1 kilogram of an object, right? So that is the definition for the Newton. That's the definition for Newton. Okay, write down 1 Newton is the amount of force required, to provide 1 meter per square second, 1 meters per square second acceleration to 1 kilogram of object, 1 kilogram object of 1 kilogram, right? So we have 1 Newton is what? If you have 1 kilogram of an object, acceleration that should be given to as 1 kilogram is 1 meters per square second. So we need 1 Newton of force. So that is by definition, right? That is by definition. If we have an 1 kilogram of object, and let's say you need to provide that 1 meters per square second acceleration. So the amount of force required is we define as 1 Newton. Okay, so that is the definition for a 1 Newton. Then you can substitute all those in this equation. So force is 1 Newton, K, mass is 1 kilogram, acceleration also 1. So what is the value of K? K is equal to 1. Okay, so if you are solving problems using this equation, I mean using Newtons, right? You can use this equation, F equals ma, that K becomes 1. Okay, K becomes 1, but all the questions you get will be from Newtons, right? So always you can use this equation. But if you have like different units like pounds or something, they won't ask question like that probably. Then you can't use this one. Many questions they ask from newtons, right? So you can use this. The k becomes 1. Okay, take it down. Take everything down, right? Including these two. Then this one. Right. Then try 6 question. 6. Please send the answer on the chat box. What's the answer? That's an easy question. What's the answer? Question number 6. MCQ. I think you have the tute, right? Please wait a little, right? I think. Everyone, please download this tute. I just sent you on the group. Yeah, so download the tute, right? I just sent you on the group now. From that tute, try 6 question. That is the easy question, and send me the answer in the chat box. Yeah, 4th one, right? It is easy. I don't think I need to explain that. So all the forces are to the same side. So it has the highest unbalanced force. 4th option has the highest unbalanced force. So the answer should be 4th one, right? If unbalanced force is higher, acceleration also is higher. Then try first question. Send the answer in the chat box. So what they're asking is this capital F. What is this capital F? It is not like a single force, right? It is a resultant of a bunch of forces, like unbalanced force. Let's say you have like a bunch of forces from here, like this. You need to get the resultant of all these. These are external forces. External means the forces are applied from outside objects, not internal. These forces are not caused from within the object. All these forces are caused by external objects, right? So the answer should be second one. You have to get resultant of all these forces. Resultant, you know, right? Like resultant is the single force that can replace all these forces. So it should be the so it should be second answer. Then at the back you have some essay questions. Just try the first essay question. So I'm like solving all the easy questions first, right? First question, essay questions, first essay question. What's the answer? Did you get the answer? Okay. So they're asking linear momentum. So what is linear momentum? You know that momentum is just mv, right? Mass times velocity. So mass is 5 kilogram. Velocity is 3. So it is 15 kilograms per second. Since the velocity is to the right side, linear momentum also is to the right side. So that is an easy question. Then try second one. Second question. So 100 gram of ball means mass is 0.1 kilogram. Mass is 0.1 kilogram. Hits the wall at 30 meters per second. then bounces back at 20 meters per second. So just before it hits the wall, before hitting the wall, the momentum is 0.1 times 30. You have to mention the direction as well, because direction is important. Yeah, so this is 3 kilograms meters per second to this side. First question. Second one, 0.1 times 20 to this side. So it is 2. 2 to this side. Third one, change of momentum. This is very important, right? Delta P is final minus initial, not initial minus final. It should be final momentum minus initial momentum. So final momentum is this one, right? 2 to this side minus initial momentum 3 to other side. So this is a vector calculation. 2 to this side, you can change the direction of the arrow and make it a positive. So change of direction of change of momentum is to this side. So this is the change of momentum. At the last part, direction is very important, right? Direction is important. Okay. So I think now you know some stuffs about this momentum, right? I just wanted you to get familiar with those. Then write the topic, Newton's third law. Newton's third law. Write down every action has equal and opposite reaction. Every action has an equal and opposite reaction. So action here means the force, right? So any force has an action force and a reaction force. Anything has an action force and a reaction force, right? There are no like single forces. Any forces has an action and a reaction. Any force. I'll explain that using a simple diagram. So this is a box placed on a plane. Box placed on a plane. So they might ask to draw the free body diagram. Free body diagram means all the forces acting on the object. They ask free body diagram for the box. So you have to include all the forces acting on the box. So we know normal reaction force is acting on the box and the weight of the box. So those two forces are acting on the box, right? So that is what we draw when they ask you to draw free body diagram. But so this capital R, who creates this capital R? By flow on box. By flow on box. By flow on box. So how to find the reaction force of this? You just have to change these two terms. So the reaction force should be by box on flow. You just have to change these two objects, keep or change by on. So that reaction force by box on flow is upward, downwards, capital R. But we don't mention when they ask you to draw free body diagram, right? This is the reaction force, right? Then what about this W? Weight. Weight is applied by earth, right? Weight is due to earth, by earth on box. Then the reaction force of this weight should be, how to find that? It should be by box on earth. So that reaction force is by box on earth. That reaction force is somewhere here, upwards. But we don't mention these forces, these two forces, when they ask you to draw a free body diagram for the box. Because these forces are on other objects, right? On earth, on box. We only mention on box forces. So this is on box. This W also is on box. This force is on earth. So we don't mention that. That is on earth. But those forces exist, right? But we don't mention that. So this force also we don't mention that. Got it? In the PDF, further details are given. Just try that, right? I mean, study that in the PDF more clear. I don't have the time to explain all those. So in the PDF later you can try that. Right, then try third question. Third question. The Zoom account is not upgraded today, so I'll resend the link, right? You can rejoin that when I send it again, right? It's not been upgraded, that's why. Try the third one, then I'll send the link again to the group, then join everyone, right, to that one. Meanwhile, try the third question. The equation you have to use is this one, right? F equals mv minus mu divided by time. So the mass is use this equation and get the answer. Mass is given, velocity is given, everything is given, right? Try the third question. Okay. So the mass is mass V minus U divided by T. So the mass is 1200. Okay. Velocity is, gained velocity is 4. Initial velocity 0 divided by time. Time is 3 seconds. Got it? 1, 8. So 800. 800 times 4. 32. 3200. 3200. So the answer for that should be fifth one, right? Answer is fifth one. Then try fifth MCQ. Fifth MCQ. 20 kilogram moving at 15 meters per second. It stops due to a applied force, let's say somewhere here. What they ask is distance it moved before it stops. Okay. So first thing you have to apply F equals ma to find the deceleration. So force is it given? The force given 50 Newton. Resistive force is 50 Newton. Mass 20. Deceleration actually. If you want, you can put a minus here, because you are applying the equation to this side. So this force is to the opposite side. So this becomes a minus. Then acceleration is equal to 50 over, you can divide by 10, 5 over 2. So that is, deceleration is minus 5 over 2. Okay, that is the first thing you have to do, find the deceleration. Then they ask you to find the distance. So what can we do to find the distance? You can use one of the linear motion equations, right? Since no time is not involved in this question, this is the only equation without time, linear motion equation. Final velocity is 0, right? Initial velocity is 15 squared, plus 2 times, this is a deceleration, so minus 5 over 2 times s. 2 cancels off, take this to the other side, 5s equals 15 squared means 225, divide by 5, 45 meters. 45 meters. So that's the distance the object moves before stopping. So this type of question we needed F equals ma. Yeah, second answer. So we needed F equals ma and a linear motion equation as well, right? Right, then try 7th question, 7th MCQ. So what they ask is net resistive force. When the accelerator is released, only a resistive force is applied on the object. Okay, let's see. mv minus mu. This equation you can apply. Take m out. So mass is 1000. You can just substitute and get the answer. The more important thing is you need to think about the directions, right? So I'll apply this equation to this side. So the final velocity is 10, right? But since that final velocity is to this side, it is a plus, because I am applying the equation to this side. Minus initial velocity also is to that side, so that also is plus, minus 20. This minus is in the equation, right? Then divide by time. Time is 5. So what do you get? You get actually a negative value. 1000 times 10 minus 20 minus 10 divided by 5. 2. So it is minus 2000 Newton. So why did we get a negative sign here? Negative value. I apply the equation to this side, right? So force you got is negative. What is the meaning of that? Actually the force should be the opposite side. Force should be to the opposite side, right? So to opposite side, force is 2000 Newton. Actually, this force should be mentioned here. Even if we mark the force wrong, at the final answer, if you did the substitution correctly, at the final answer you get the correct direction, right? Yeah, so the answer is fourth one for the seventh question. Then try ninth question. Question number 9. First, you have to draw a sketch for that. Attached to a bottom of a lake. They say the tension is 60 Newton. This tension is marked like this, right? So that tension is 60 Newton. Because this tends to go up, this holds the tension. So you have to mark all the forces acting on this object. There's 120 Newton downwards. That is the weight of this 120 Newton downwards, and there's an upthrust force. So due to this upthrust means the force applied by the water on the object upward. That's why it's trying to go up, right? So upthrust 120 Newton downwards and 60 Newton downwards. So under these forces, this object is at equilibrium. Equilibrium means it is not moving, right? It is at rest. Now you just have to apply F equals ma to this case. This is before cutting the string. So upwards, what are the forces? U is upwards, so it is a positive. 120 downwards, it is a negative. 60 is downwards, it is a negative. Equals, it is not moving, so it is 0. It is not accelerating, right? So 0. So from this one you can find upthrust, U. We learn about upthrust more in hydrostatics, right? Okay, now we found upthrust, 180 Newton. At the second scenario, what happens is they cut the string. So when they cut the string, there's no tension. Upthrust still does not change, right? Upthrust remains at 180 Newton. And this has a weight 120. But now this doesn't have a tension. So what happens? Now there's an unbalanced force upwards. Now it starts to accelerate. What they ask is that acceleration. Just again apply F equals ma. So 180 minus 120 equals weight of the object is 12, acceleration. So this is 60 equals 12a divided by 12. So acceleration upward should be 5 meters per square second. Yeah, the answer should be the fourth one, right? Answer should be fourth one. If you didn't get something, tell me, right? Then try 11th question. 11th question. First draw a sketch, right? Then the question will be clearer. Then you just have to apply linear motion equations, F equals ma, those stuff. So coconut falls from a 5 meter height coconut tree. Mass of the coconut is 0.5 kilogram. 500 grams, right? So 0.5 kilograms. When it hits the ground, what happens? It penetrates the ground to a 25 centimeters. 25 centimeter, I'll mark that as in meters, divided by 100, 0.25 meters. It hits the floor with a velocity, let's say u, u velocity, then at this depth velocity becomes 0, right? It comes to rest at this position, right? First thing you have to do is you have to find this v, I mean u. So what should you do to find that? Just apply a motion equation from here to here. So final velocity, I'll take it as v. Final velocity v, initial velocity 0, plus 2 times acceleration 10, right? Because this falls under gravity. Acceleration 10, height is 5. So this is 100. V squared equals 100. Then V equals 10. Okay. So we found that this velocity to be 10 meters per second. So this velocity is 10 meters per second. That is the velocity it hits the ground. Then inside the ground, it decelerates. It decelerates and comes to rest. So what do they ask? A resistive force. What they ask is resistive force. Right. So inside the ground, what are the forces acting on the coconut? Inside the ground, it has a resistive force acting on the coconut. That's why it stops, right? Resistance caused by the ground on the coconut. It is upwards and there's a weight. There's a weight. So under these two, this actually decelerates. This decelerates. I'll put simple A to this side. Again, I'm applying, let's say this is 1, 2, then 3. I am applying this equation again from 2 to 3. This is inside the ground. So final velocity 0 equals initial velocity now is this one, right? 10. 10 is squared plus 2 times deceleration, we don't, let's say simple A, and the height it penetrates the ground is 0.25. Then this is 100. Take this to the other side. 2 times 0.25 is 0.5 minus 0.5 acceleration. So acceleration is minus 200 meters per square second. Actually, we got a negative value because this is a deceleration, right? It decelerates actually. This is a very large deceleration. Then what you have to do is just apply F equals ma. That is for the motion inside the ground. 2 to 3. Okay, so what are the forces? Mg downwards, resistive force upwards. I'll just apply, no, fine. To any direction you can apply that, right? So Mg downwards, you have to think of, for a question like this, you have to think carefully of the directions, right? Mg downwards, resistive force upwards equals mass times acceleration. Then just substitute. So mg is 0.5 kilogram times 10. So so that weight is 5 Newton, right? Weight is 5. R is what we need to find. Mass is 0.5. Acceleration downwards negative. Okay, acceleration downwards, see that? To this direction it is negative. So you substitute minus 200. So this means minus 0.5 means half. 200 times half is minus 100. So take r to this side, 100 to this side. 5 plus 100, r to the other side. Then this becomes 105. 105 Newton of force. Okay. Take it down if you have any issues. Take it down. And if you have any doubts, the answer should be third one. If you have any issues, please send me in the chat box, right? Answer is third one, right? Got it? Please send me some thumbs up if you have taken this down and have no issues. Right. Then try 12th question. 12th question. So we have this. If you have an acceleration to this side, so by intuition you know that the water level gets like this, right? Because from this side water level gets compressed. So it rises from here, lowers from here. Got it? Water levels becomes like this. Okay? If an object accelerates to this side. That's the first thing you need to know. Then the thing is, if you have a object trying to float, this is trying to go up, right? What happens is, I think you know hydrostatic pressure, that is H rho g. We'll talk about that later, right? For now you know H rho g. So what about height from this side is higher, height from this side is lower. So this side, let's say the pressure is P1, at the other side pressure is P2. So this hydrostatic pressure is H rho g, right? So this pressure is higher. It is due to this shape. P1 is higher, P2 is lower. Now what happens? It has a pressure difference at the both sides. Pressure difference at the both sides. So this bends like this. If you want, you can draw this. So the final shape would be like this. It bends like this. When it accelerates to this side, it bends to this side. Okay? So you are supposed to know this stuff. Bends like this. Other thing is, if you have a pendulum hanging on a trolley and the acceleration to this side, by intuition you know that this tends to the opposite side, right? If acceleration to this side, it is to the opposite side. But it is different in this case. It is exactly the same direction as acceleration. So you are supposed to know these differences, right? So for a floating object, it bends to the same direction as acceleration. But if it is a pendulum hanging in air inside a trolley, if the acceleration to this side, this blob bends to this side. This one you know, right? You have seen this many times. But this one you are supposed to know, right? Answer is third one. Answer is third one, yeah. Try 22nd question. So I gave you this question. There's a different form of Newton laws that you have to apply when you get a question like this. So this is the form, right? Just pay attention to this. So we know this is the force. Force is mv minus mu divided by time. Okay. So what you have to do is take simple m out and write t here. So you get this equation. So now the unbalanced force is this much. So this is applicable for those. Okay. Okay. I think everyone hears me. Okay, right. Okay, these are regarding when you have a water flow or a air flow. So those air flows and water flows can exert a force on an object, right? So let's say I'm having a water flow onto this board. So that due to the collision of that water particles, it causes a force on the board, right? So you need to form. So under the syllabus, you need to form this equation so you can apply under those circumstances. Right. So this is the equation, right? This is the fundamental equation. Then take m out. Then you get t here, v minus u. Right? V minus u. So what is this? Mass over time. Mass over time is mass flow rate. Mass flow rate means kilograms per second. Per second amount of kilograms. So for that, there's a symbol called m dot. Whenever you write a rate, flow rate or something like that, you can put m dot here. Then you get v minus u. So this is the form of F equals ma. You need to apply for a question whenever you get a question regarding flow rates. It could be volume flow rate or it could be mass flow rate. So mass flow rate is measured in kilograms per second. Volume flow rate is measured in what? Cubic meters per second, right? Volume divided by time, cubic meters per second. But here what you got is a mass flow rate. Another thing is you need to know this equation to apply for the mass flow rate. Mass flow rate is equal to A. I'll just write it here. Mass flow rate is equal to what? AV rho. You need to know this. What is A? A is the cross section of the flow. A is the cross section of the flow. V is velocity. It hits the ground, hits the wall. V, right? Incident velocity, V. Rho is the density of the liquid. Rho is the density of the liquid. So AV gives us the volume flow rate. A means cross section, square meters. V means meters per second. So what do you get from this? Cubic meters per second. So that is a volume flow rate. Multiply by density. Density, what is the unit? Kilograms per cubic meter. So if you multiply that, what happens? This volume flow rate converts into a mass flow rate. Per cubic meter cancels off. Then it becomes kilograms per second. Kilograms per second. So that is just to prove you that this gives you mass flow rate, right? So you can apply this equation as well, AV rho, to find m dot. Then you can substitute AV rho here. V minus u is similar, right? V minus u. First take this down, right? First take that down. If you're taking it down, send me a thumbs up, right? And if you have an issue, tell me. Once you taken this down, try 22 and tell me the answer. So you have to apply this equation there. If you got the answer, send me. Okay, so it hits the wall at V and jumps off at V over 2. So what is F here? Regarding the question, this one, right? So m dot is AV rho. It doesn't change. It is just AV rho, right? Instead of m dot, you can put AV rho. Then velocity. What's the final velocity? Final velocity is V over 2. You have to think about velocity is a vector, right? So you have to think about directions. So v over 2 is to what direction? This side. Minus u, initial velocity is to this side. That is v. Okay. So AV rho. So v over 2 to this side. You can change the direction of this v. Then it becomes minus plus. So what is this? Now you can add these two. AV rho to 3v over 2. V plus v over 2 is 3v over 2. Okay. Then there's a v here as well. Then you can write it as 3a rho v squared divided by 2. So this is the force applied by the wall on the fluid due to collision. Got it? You can take it down. This gets squared, right? 3a rho v squared divided by 2. So that is what you have to do when you get a flow rate question. Right. Then try 16th question. 16th question. First draw is the sketch, then try 16th question. So what they ask is, so you know that due to the contact, normal reaction forces are acting between these two, right? This force is by capital M, this force is by simple M on each object. So what they ask is an expression for normal reaction force. Okay, expression for normal reaction force. So whenever you get a question like this, you should have the ability, this is also a key point in Newton's laws, right? How to mark a system. First I'm going to apply to the whole thing at once. This is just to find the acceleration for whole system. So the thing is, when you think about the whole system, you apply to the whole system at once. Whole system means capital M and simple M. Okay. These two forces become internal forces. Get it? These are action reaction forces. When you consider the whole thing, these two becomes internal forces. They cancel off. All the time internal forces cancels off. Then only external force on the system is capital F to this side. That is the only external force. Then I substitute that here. What's the mass of the system? Capital M plus simple M. Acceleration. So we found the acceleration first. Term for acceleration. It is not what they ask. What they ask is capital R. Then I am going to apply F equals ma. Simple M only. Simple M only. So when you consider simple M, what is the force on simple M? Capital R is the force. That is the only force on simple M to this side. So system is like this, right? You can separate the system like that. Now this is not an internal force, right? This is an external force to simple M. But for the whole system, it is an internal force, capital R. But for simple M only, if we consider only simple M, this force is an external force. So just substitute it here, capital R to this side. Mass is simple M. Acceleration. What is acceleration? This acceleration, right? Then you can plug it here. F divided by simple M plus capital M. So MF divided by simple M plus capital F. take it down. If you have issue, please send me in the text chat box. This system, identify the correct system is the key here, right? If you get that, please thumbs up. I mean, once you've taken this down, thumbs up, right? Right. Then try 20th question. 20th question. First draw the sketch, 20th question. So we have this pulley system. So mark weights first, all the weights. Let's say between B and C, the tension is T1, right? We have a different tension between B and C, T1. And the tension of this one, T. This is the same string, so we have the same tension all over here. But this is a different string. So we have a different tension, that is T1. So what they ask is T1. It is clear that this whole system accelerates to this side, downwards, right? Because this part is heavier. Let's say it accelerates downward at simple A. Then this goes up at simple A. Then you just have to apply F equals ma to each part, and then you can find T1. That's what you have to do, right? So with practice, you can be efficient doing this, right? Otherwise, the minute you see the question, you know to which ones should you apply F equals ma, right? But that comes with practice, right? First, I'll apply to 2 kilogram upwards. You have to define the system. F equals ma to 2 kilogram. So what are the forces? Upwards T, downwards minus 20, equals mass is 2 kilogram. Acceleration we don't know. So that's the first equation. First, when you get a question like this, first thing is you need to find acceleration. To find anything else, first you need to find acceleration, right? Right. Then I'm going to apply equation to B and C both at once. Both B and C, I'm going to apply the equation at once, right? Why is that? I need to get, there are two forces, T1, two forces here. I need to get rid of that, T1. So when you apply to both at once, what happens is, these tensions becomes internal forces. Then they cancel off. Okay. So what are the forces? External forces, 20 Newton here. That is applied by the earth, right? 20 Newton here, applied by the earth. So there's a 40 Newton downwards. Minus this tension upwards. This is external tension. These tensions became internal, right? Tension upwards equals mass is 4 times acceleration. So this is the second equation. Then you can add these two, 1 plus 2, and get rid of tension. So when you add this, tension plus T minus T cancels off. This is 40 minus 20. Equals 2a plus 4a, that is 6a, right? So this is 20 equals 6a. So divide by 2, this becomes 3, 10. Then the acceleration is 10 over 3. Okay, we found that. Acceleration. We know the value for acceleration. Then in order to find T1, again you cannot consider B and C together, right? You have to consider only one of these. So T1 will be in the equations, otherwise T1 won't be in the equations, right? So I'll apply that to C. Downwards F equals MA. Okay, what are the forces? Downwards 20, upwards T minus 1 equals 2 times acceleration. We found the acceleration as 10 over 3. Let's substitute it here. 10 over 3. Take this term to this side. Minus 20 over 3 equals T1. 60 minus 20. 40 divided by 3 Newton. Do we have an answer like that? Yeah, the answer is fourth one, right? 40 over 3 newtons. 40 over 3 newtons. Now all the types of the questions we have discussed, and if you've taken down this, please thumbs up. Right. All the types of the theory parts and the questions are discussed, right? And if you have any questions from these and issues from there, try the remaining questions. And if you have any questions, you can send me a message, right? Then on the next week, we'll start a momentum conservation law, completely only momentum conservation law. It is somewhat of a, students find that a hard part, right? There are many MCQs from that part actually, momentum conservation law for in the MCQ paper. So the next class will be on Thursday, next week Thursday at 8 p.m. right? Okay, so we'll see you there. Okay, good night.